So again, we have a mini quiz today. Translation around. Alex, what are you doing over there? Sarah, Alex, your seat is up here. Move back. You're sitting over there.
Wait, where are the colors of it?
Alright, so a reminder, you should have done your JLab by today. It is due today, the first 10 question quiz. I have gotten some of you, I think Morgan I received, Mohammed I received.
Mohammed.
Kajal, yes, I got yours. Is that a question? It's due today, so you better do it today. So if you did not do it, make sure you send it in today. Remember, you're allowed to retake it as many times as possible. You need to send us the score that you want recorded, though. Anything submitted after today receives late credit. The later it is, the less credit you get. So make sure you get it done. Yes, Kira. This first one is a 10-question quiz. So make sure you follow that paper, the instructions for how to fill out the proper boxes and submit the results. Also, make sure that you take either a screenshot of it or print off your results in case something happens and your email doesn't go through to us. Maybe you typed in the email incorrectly. It is up to you to make sure you show us the results in another format. So I would recommend that you either print off the results or do a screenshot and save that and verify with us that you got the result, that we got the results. Yes. What'd you say? It's on the paper that we gave you, and I also posted that paper on Blackboard, and it's also up on Blackboard. And there are extra copies of the JLab paper over there in the bin, so if you want to make them copies.
You should send it to whoever's name was on your roster at the beginning here, that list that you got for all your periods. So if you send it to either one of us, go forward, so it's not the end of the world. Just try to do it to yours while you get through.
Alright, other questions about the JLabs? Remember, it's an easy way to boost your grade because you can get 100%. All you have to do is the work of redoing it over and over again to get the grade that you want. Okay, so we do have a mini quiz today. We have mini quizzes for this unit. The last what we learned last class was solving using factoring. So really not much that was new. We factored and then we set each factor equal to 0. Okay, so for our first problem here, when we factor, we need to first make sure it's in standard form, which we have here. Remember, we want it in ax squared plus bx plus c equals 0. Alright, so we need to first check for GCF. What is my GCF here? -2. Good. Whenever there's a negative in front, you must factor that out. Okay, so if I factor out a -2, I get x squared minus 2x minus 8 equals 0. Questions so far? Please, if you're not understanding, stop me. Ask any questions. Stop to make sure we're on the right page. Okay, so now we need to factor the inside here. So let's do our T-chart for this. I need it to multiply to the outside, so -8, and add to the inside, -2. What two numbers accomplish that first? Very good. Everyone catch on, please stop talking. -4 times 2 equals -8. -4 plus 2 equals -2. Now, can I take the shortcut here?
I don't remember. What's the shortcut?
A shortcut I can use if my leading coefficient is 1. So since I'm factoring this, my leading coefficient is 1, I am allowed to use my shortcut. If you forgot, you don't have to use it, but I'm going to save us time here. So I have x minus 4 times x plus 2 equals 0. So again, because this here had a leading coefficient of 1, I could use my shortcut, which allows me to go straight to my factors of x minus 4, x plus 2. Do not lose your GCF in the very beginning. Alright, questions so far? Alright, so far all we've done is from last unit. This one.
Could you do it without the shortcut as well?
Yeah, you can do it without the shortcut. You don't have to use the shortcut if you don't want to, but you can do it.
I mean, could you like show it?
Sure. Alright, so without the shortcut, we have -2 times x squared minus 2x minus 8 equals 0. Not using the shortcut, we have our factors of -4 and 2. So again, my GCF hangs out in front. I split up my middle term. So x squared fire the middle guy and replace him with my new factors. Negative 4x plus 2x minus 8. Still equal to 0. Do not lose your equal 0. This unit we are solving. Last unit we were factoring. The big key piece to know which one you're supposed to do, other than reading the directions, is looking to see if you have an equal 0. Equal 0 indicates we are solving, going to the final answer of x equals. If there was no equal 0, we would stop at a factor. Okay, so now we break it up into our boxes here. Again, my GCF just hangs out in front. So I can factor out an x. I've left behind x minus 4. Always put a plus sign. My second box, I can factor out a 2, and I'm left behind with x minus 4. End of the box, end of the parentheses. Still have the equal 0. So after we've boxed it up and factored out our GCFs, we check to make sure the inside is the same. Indeed it is. Again, my GCF is just hanging out in front of negative 2. Then I write my insides. Now that I've done my insides, what's left behind is x plus 2. Now we're at the same point. We're here. So again, you can use that if you've forgotten the shortcut method, but actually shortcut's a little bit further. The shortcut will become after checking. Other questions so far? P1, are you with me? Your first answer. I know, I like the shortcut method. Okay, so now this is the new piece we learned last class. Everything we've done so far is review. Now the piece that we learned last class. We take each factor and set it equal to 0. Negative 2 equals 0, x minus 4 equals 0, and x plus 2 equals 0. Now negative 2 never equals 0. So this just isn't going to yield a solution for me. It's not going to yield a 0, a root, or an x-intercept. There's no variable, so there's no answer coming from it. Now I can solve for my next ones. Add 4 to both sides. And I get x equals 4. And subtract 2 from both sides, and I get x equals negative 2. So I have two solutions here of x equals 4, x equals negative 2. And if you remember from last class, we said the degree tells me how many solutions I will have. So degree 2, so I have 2 solutions. We talked about the fact that sometimes it's just a solution repeated. Okay, Shannon, Joe, please stop. Also, we see that we have, even though we have 3 different factors, only 2 of them have an x with it, thus yielding 2 solutions. Okay? Finally, our answer should always be in set builder notation, so x such that x equals negative 2 and 4. So this is our final answer here. So make sure you are writing your answers in set builder notation. For whatever reason, the Virginia Department of Education has decided set builder notation is the way to go for algebra 1.
And remember, your smaller number gets listed first. That is hard.
Yeah. Small first. Okay. Questions on this? Pretty straightforward. You factor, then set each factor equals 0. Okay. Alright, we will take a look at homework questions next. Alright, so today we're going to learn our second lesson, which is on solving quadratics using square roots. I'm actually really excited about this lesson because this is kind of the basic format for solving that you will be using for the rest of your mathematical career. I really enjoy this because I think it's a really great way, a unique way to solve a quadratic, but it only works with specific ones. So last class we talked about that we will learn different ways to solve quadratics. We have factoring, which we've done, square roots, which we're doing today. Then we also have quadratic formula, which we will be doing later. Then there's also completing the square. That's something you'll learn in Algebra 2. And then we'll solve by graphing. So square roots today is one that can be used it's used almost as often as factoring. It just depends on the type of situation you have. So we solved by factoring when we had a quadratic that looked like this, and that it was actually factorable. But today we're going to deal with ones where we don't have that middle term, where we just have an x squared but not an x. Square roots are the best way to solve for that. Likewise, if we have a quantity squared, instead of multiplying it all out and then trying to factor, it's much easier to isolate that quantity squared and then take the square root of it. That's supposed to be a plus 2. Okay, so first let's review simplifying radicals. So this is something we did a couple units ago. So we have the square root of 27. Who remembers how we go about simplifying things?
2 times 25.
Good, we're going to do our factor tree. So first we start off with 2. Does 2 go into 27
No.
evenly? No. How about 3? Yes. 3 times what? Good. 3 times 9. Alright, what's our smallest prime that goes into 9? Good, another 3. And 3 goes into 9 how many times? Okay. And then finally 3. Okay, so square root, so we have to have 2 of a kind. So we circle our groups of 2s.
3 times 3 is 9. 9 on the top.
So we have one group of 3s. That comes out as one single 3 in front. Then I have a 3 that's left over, and that stays inside. So this is just 3 root 3. So this is just 3
But
root.
if there's another 3, would it be 9?
Yes, so if there was another 3 to make a second group, then we would have 3 times 3, which is 9. Alright, any questions on number 1? So again, this is just review of what we did a couple units ago. Now, what about the square root of negative 36? First of all, is 36 a perfect square?
6 times 6.
Yeah, 6 times 6. So 36 by itself is a perfect square. But we have this negative underneath here. Someone take out your calculator and punch in square root of negative 36. What happens? It says error. Does anybody remember why?
Negative.
You
It's a
what?
negative.
No? Because what?
Negative.
There's a negative underneath. We can't take a square root of a negative number. It gives us a non-real answer. So that's what we put
It's
non-real answer. It's not fake, it's an
Fake.
imaginary number.
Not real.
So the actual answer to this would be plus or minus 6i. But again, you're not going to deal with that until algebra 2. Alright, number 3. Is 48 a perfect square? Can we easily do the square root of 48? Punch in your calculator.
No.
What'd you get, Rachel?
7.
A decimal. So we can't just do a perfect square, so we have to break it down. Does 2 go into 48?
Yes.
24. 2 goes into that, we get 12.
6.
2 goes into that,
3.
2 goes into that. 3 goes into that. Okay, so we've got a group of 2, another group of 2, and a lonely 3.
It's 1 outside and 3 in
Very good. So 2 comes out and another 2 comes out, so 2 times 2. And left underneath is 3, so it's just 4 root 3.
We remember when it comes out, it's times each other. A lot of you are still adding. In that case, because it's off the 4, but on the other ones, it's not.
6 plus 3 is
Remember when you put them back together, it's multiplied.
6 plus 3 is 9.
big.
Yes, this is all multiplication. Alright, so number 4, we have square root of a fraction. And we should remember our property that this is square root of 4
And then
over square root of 9. What is square root of 4? And what's square root of 9? So our answer is 2/3.
What if there's like a big number?
So say it was like
7. 7 over
square,
12.
what?
So
7 over 12?
7, yeah.
So we would have square root of the top, square root of 5. Square root of 7 we can't break down, so that would stay as square root of 7. But square root of 12 we could break down,
3.
so it would be 2 root 3. And then there's something else you have to do in mathematics. Just like in English, you have to start a sentence with a capital letter and end with a period. In math, we have certain rules about formatting as well. And one of them is that you cannot have a radical in the denominator. So you'd have to do what's called rationalizing. That's something you haven't dealt with yet. But what we would do is multiply by square root of 3 on the top and bottom. And that would give us square root of 21.
7 times 3.
7 times 3. And then square root of 3 times square root of 3 is just 3. 3 times 2 is 6. So this would actually be 12.
But don't worry about that
But
right
you don't
now.
have to do it. You
Do
won't
not
get
worry
this
about this, please.
When?
When,
When
so,
am I gonna?
next year.
Do it.
Next year. It's called rationalizing, which I like because it sounds like you're doing something really intense. Rationalizing. Okay. So this is just some review of radicals because what we're dealing with today is a lot of radicals because we're solving by using square roots, which is our radical. Okay, let's go and fill out this first chunk of our notes. Exponents and radicals are inverse operations. An operation is what you do to a number. Addition is an operation. Subtraction is an operation. It's taken away. Multiplication, division, those are all operations. Absolute value is an operation. Square root is an operation. Any power is an operation. And inverse operations are two operations that undo each other. So just like if I had x plus 3 equals 5, the inverse operation of adding is subtracting because it gets rid of that, it undoes it. If I had 2x equals 14, the inverse operation of multiplying is dividing. It's the way to undo that. So similar to today. Exponents and radicals are inverse operations. So if I have x squared equals 100, the way to undo that, the opposite of squaring, is square rooting. Is to do the inverse operation square root. And that's what we'll be doing today. It's the way to undo, the way to get rid of your exponent. So that means that in order to undo one when solving an equation, we must do the other. We have to do the opposite, the inverse. Remember, most square roots have two answers. Two answers. Okay, so in order to solve, what we first need to do is isolate the exponent. So we're really following the same process that we had before for all other solving equations. Before that, we just had x, we didn't have x squared. But now we have an x squared. So before we had, let's say, 2x minus 3 equals 10. We would do PEMDAS or GEMDAS backwards. We would first do our addition subtraction. 2x equals 13. And then we would do multiplication division. Then you would get rid of exponents and get rid of differences. We would do GEMDAS backwards whenever we were solving. Notice what we were doing here is trying to get x all by itself. We're still trying to get x by itself, but our problem now, if we look at number 2, our problem now is that x is trapped by an exponent. So before we can get x alone, we have to get x squared alone. So that's what it means by isolate the exponent. So then number 2 says, after we've isolated the exponent, then use a radical to undo the exponent. And make sure you do not forget a plus or minus. Anytime we take a square root while we are solving, we must have plus or minus. Whenever we take the square root while we're solving, we must have a plus or minus. Okay, so let's go ahead and do number 1 and then number 2. First of all, is this squared by itself? Yeah, there's nothing else with it. So what's the way to undo a squared?
Use a radical.
Use radical. And since this is a squared, we're going to use a square root. Can you guess what we would use if it was a cube? A cube root. What if it was the 4th power? A 4th root. Alright, so square root of x squared. My square root cancels out the square. So these are canceled out, so I have just x equals, what is the square root of 3. And whenever you take the square root and you're solving, you must have plus or minus. Because if we take these and put it back into your equation. 3 squared does indeed equal 9. And negative 3 quantity squared also equals 9. That's why we have to have both a positive and a negative. Because when it gets squared, the negative times negative is positive. You writing this down?
Are you mad?
Alright,
Undoing it with a radical is kind of like the same thing we do with to undo addition. We subtract. Division, we multiply. Undo squaring, square root. Same idea.
alright, we need to write our answer in set builder notation. X such that x equals negative 3, positive 3. Honestly, I'm okay if you just leave it like that in your set builder notation. X equals plus or minus. Alright, number 2. Well, first of all, any questions on number 1? Pretty basic, right? Not too bad. Same idea solving, just know it to get rid of that square root. Or that. Okay, so number 2. Notice x squared has something else with it. Sometimes I like to take my thumb and cover that up to see what else I need to get rid of. I need to get rid of my negative 20. How do I do that? Oh, 20. So then I have x squared equals 20. Alright, so now that x squared is all alone, now we can take the square root. So now we do the square root of both sides. So x equals, again, square root and square root cancel each other out, plus or minus square root of 20. But we need to always simplify our radicals.
You can't enter decimals.
Alright, it gives you decimal. It's not a perfect square, so we need to go ahead and break it down. 1 for 2 and 10. 2 and 5. And 1. So x equals plus or minus 2 root 5. Group of 2 comes out in front. My 5 is still underneath. Again, in set builder notation, x such that x equals, I'm fine if you write it together, just one thing. Plus or minus 2. Notice we have 2 answers. Degree 2, 2 solutions. The positive is a solution and the negative is a solution. They're 2 different answers. Alright, questions on that? Okay. Let's take a look at...
Well, there's a fly.
Let's do number 6. So number 6 right now, x squared is not alone. We have to get rid of that 18. And Trey, what did you say we have to do? Good, divide by 18. So I'm left with x squared equals 2 over 18. What does that reduce down to?
1 over.
Good, 1 over 9. Reduce it down, you can. Good. Alright, now it's down to just 1/9 and x squared. Since x squared is alone, Kadra, what are we going to do? Now that x squared is alone, what are we going to do? Good, now we square root it. It's only x squared, so now we square root it. Square root both sides. We should all be writing this down.
Sensation. Yeah.
Square root of x squared is x. It undoes the exponent. And we have plus or minus the square root of 1 over 9. Now we reviewed a problem like this. How do we do it? What do we do? We have to simplify, right? What do we do?
Square root over 1, second, and then you can square root over 3.
So we have square root of 1 over square root of 9, and that reduces down to what's square root of 1? And what's square root of 9? Good. So notice we don't have the radicals anymore. After you've taken the square root, yes. After this says take the square root of. Once you've taken the square root, you don't need it anymore. So we have x equals plus or minus 1/3. So again, in set builder notation, x such that x equals plus or minus 1/3. You can always check your answers. Take 1/3 and put it back in for x. See if 18 times that gives you 2, and it does. And take negative 1/3, put that in for x. 8 times negative 1/3 times square root doesn't need it. Alright, questions on that one? Okay, now let's take a look at a trickier one, such as number 10.
He's actually better than Adam.
Better than Adam.
I think so.
So flip it over to the back side. Let's take a look at number 10.
Adam's on worse than Steve.
Gentlemen. Stop talking. Looking at Alright, so here we don't have just the x's squared, but my entire quantity here is squared. So I need to isolate that whole thing. I need to get rid of everything outside of it. We don't distribute exponents when we are adding inside. What you would have to do is FOIL it out. And we don't want to do that. That's more work than we need to. Yes. So I need to isolate this by itself. So what do I need to get rid of then? The 2. And how do I get rid of this 2? Good. Subtract 2 from both sides. So I have 2x plus 4 quantity squared equals 36. Notice there's nothing else outside of my parentheses. Now that my parentheses squared is all alone, now I can do the square root. So now then, what is square root of 36 going to be?
6. My name's Nana.
Naman, do you agree with Trey? Yes. So again, my square root and square cancel each other out. So now I'm left with just 2x plus 4 equals plus or minus 6. We still took that square root while solving. We must have the plus or minus.
So that's how you get rid of it. You just,
We're not done yet.
I don't know.
Okay. Any questions so far? Yes. Yes. So square rooting eliminates your square. Now that I just have this squared, I'm going to take the square root. It eliminates my squared, so I no longer need the parentheses, so it's just the inside. Whereas before it was just x, now it's just the inside. Only x is squared, and this whole thing is squared, so that's what's in. Other questions so far? Okay. So now it's kind of weird if I subtract 4 while it's still in this format. You have to think positive 6 minus 4 and negative 6 minus 4. So let's write it as 2 separate equations. Okay. So first we have I have 2x plus 4 equals positive 6. Are we all writing this down?
Yes. Are we?
And 2x plus 4 equals negative 6. So notice I've just rewritten as 2 separate equations, positive 6 and negative 6. Pick the positive from my first one and negative from my next one. Now we just solve it like normal. Yeah, you needed to write it as 2 separate ones. Because otherwise, when you just subtract 4, what a lot of people think is it's plus or minus 2. When in reality, it's positive 6 minus 4, which is 2, but negative 6 minus 4, which is negative 10. So it's 2 and negative 10.
There's 2 slices.
Oh boy. Okay, so now when we solve, we get 2x equals, we subtract 2 divided by 2. We get x equals 1 over here. Do we agree?
Yeah, I agree.
Abdul?
Looks like negative.
It's downstairs.
Negative 10 is that
Subtract
negative
1 from both sides. I get 2x equals negative 10. So this here is why we can't just do it in our original equation. It's not plus or minus 2. It's positive 2 and negative 10. Then divide by 2. We get x equals negative 5. So in our set builder notation, x such that x equals negative 5 and positive. So again, we need to get the squared alone, whether that's just x squared or parentheses squared. We need to get that alone first, then you can do the square root. Questions on that? Okay. Let's take a look at,
11.
is that the one with the variables? Oh yeah, let's do number 11.
Yeah,
That's a good one. Okay, we need to get x squared alone. So what do I need to get rid of first?
plus.
The 7, good. I add 7 to both sides. We should all be writing this down. Negative 25 plus 7. What's that?
Negative 18.
Good. Negative 18. Now we've got a pesky negative 1/2.
Do the opposite.
So right now, it's negative 1/2 times x. The opposite would be to divide, but what is something else we can do rather than dividing by a fraction? Do you guys remember what
1 times 2 negative.
we multiply by the reciprocal?
Elliptical.
If you want in your calculator, you can do negative 1/2 divided by negative 1/2 and negative 18 divided by negative 1/2, but I feel like that's a little complicated. It'd be easier just to multiply by the reciprocal. So this would cancel and just give me a positive 1
You don't
x
have to do
squared.
that. You can just cancel that out.
As long as you multiply by the reciprocal. And then what's negative 18 times negative 2? It is positive.
36.
Good. Positive 36 over 1 is just positive 36. And again, if you punch that into your calculator, negative 18 times negative 2 over 1, or negative 18 divided by negative 1/2, you would get positive 36. So use whatever method helps you out. Right. Now it's just x squared, so we take the square root of
6.
this. Not just 6, but
Oh, plus or minus.
good, plus or minus 6. Again, 2 answers has degree 2.
6 plus 6 is
Alright. Real quick, I want to take a look at least setting up that last one. I know we spent time as we went over our homework dealing with word problems. This is again the same idea, but notice that here it's just an object is dropped. So it's dropped to the ground. This is the equation that they use to model.
That's pretty close.
And the reason is because if your initial velocity, I'm not throwing it down, I'm just dropping it, so the initial velocity is 0, which is why we no longer have that middle term. So again, S is representing the initial height, just like before, and T represents time. So it says use the equation to discover the time it would take for an object to hit the ground. What is the height if it's at the ground? 0. So our final height is going to be 0. So h equals 0. Okay. So our setup is going to be 0 equals negative 16 t squared plus 64. And this shouldn't say at the following speeds, it should say at the following heights. So an object that's 64 feet off the ground, how long will it take for it to hit the ground?
We rewrite it. So it's, we'll rewrite it 64 and
Do whatever you want.
Yeah, you can rewrite 64 minus 16t squared, or you could add 16t squared so it's positive. Either way would work. So I'm going to subtract my 64 from both sides. So I get negative 64 equals negative 16t squared. Then divide by negative 16. We get 4 equals t squared. When I take the square root, I get t equals plus or minus 2. But we're talking about time. Can I have a negative time?
what's 64 minus?
No, I can't have a negative time. So my answer is going to be only positive 2 seconds.
What's 64 minus 16?
64
divided.
minus 4. 64 divided by 16.
T squared equals.
Alright, so I'm passing out your homework to you. It is worksheet 5. We do have a mini quiz next class, so make sure you come see us if you are struggling with this. Also, a reminder, your next J-Lab is due next Monday. You are welcome.
And this advantage is T equals plus or minus 2.
Yes, but we're talking about time. Can you have a negative time?
So it's just plus 2.
So it's just positive 2 seconds. And guys, it's good for these word problems to write out what it is we're talking about. 2 seconds, not
Talking about
just
space, man.
So you're gonna have space.
We'll be in that space.
Alright, so let's take a look at number 5. We'll go back and do the ones that we kind of skipped over here. Same concept, same idea, we'll just put a lot here. So we have x squared plus 36 equals 0. Again, we need to get the x squared by itself. So if I cover this up, I still need to get rid of the 36. So subtract 36 from both sides. And I then have just x squared equals negative 36. And if I take the square root of each, square root of the x squared cancels out, so that gets rid of your squared. So we have just x. Remember, x squared, square rooted. The square root and the squared cancel each other out. They're inverse operations into each other. Now, if I try to do square root of negative 36, this is the issue we ran into earlier. We can't take a square root of a negative number. So x is, when you put in your calculator, we get an error. So it's non-real answer. So non-real answer. We're done there. Again, when you get to algebra 2, you'll learn what that actually is. It'll be plus or minus 6i. Alright, number 9. So we have a couple things we need to get rid of. And if I cover up my x squared, I see that I have 3 times that and also minus 53. I need to get rid of addition subtraction first. Get rid of those limbs. So I have 3x squared. Alright, 3x squared equals 54. Then divide by 3. The opposite of multiplying is dividing. So I have x squared equals, so 54 divided by 3 is 18. Right? So now we take the square root. Now that x squared is alone, now we can square root both sides. So I have just x plus or minus the square root of 18. But we can reduce the square root of 18. We can simplify that. So let's do our factor tree. 18, 2 and 9, 3 and 3, 3 and 1. So we have one group of 3's and a 2 left over. So plus or minus, that 3 comes out in front, and we have that 2 left underneath. So 3 square root of 2 plus or minus that. So in set builder notation, x such that x equals positive 3 square root of 2 and negative 3 square root of 2. Again, 2 solutions. We have degree 2, so 2 solutions. Okay. Then with 22, this is our last one here. Nope, we'll do 12 as well. Alright, 22. Oh, not sure why that one's not 12, but that's alright. So now we have a quantity squared. So we need to get this quantity squared alone first. So I need to subtract my 4 from both sides. And then I am left with 2x minus 3 quantity squared equals 60. Now that I have the quantity squared all alone, there's nothing attached in front, nothing attached on the end. Now I can take the square root of both sides. Again, that square root cancels out the square. Since the whole 2x minus 3 is being squared, then I can just square the whole thing. Those will cancel out their square root. So I have 2x minus 3. Square root of 64. It's a perfect square, so it's just plus or minus. Again, I need to break this into 2 equations. 2x minus 3 equals positive 8, and 2x minus 3 equals negative 8. Okay? Add 3 to both sides. 2x equals 11. Divided by 2. Okay, x equals 11 halves. 5 and a half. Over here, add 3 to both sides. 2x equals negative 5. Divide by 2. So again, x equals negative 5 halves, or negative 2 and a half. So in set builder notation, x such that x equals negative 5 halves and 11 halves. And that's our answer there. Again, if we take this and put it back into our calculator, we can double check to make sure that we do indeed have the right answer. When a solution is what makes the equation true. So if I take 11 halves and put that back into my equation, I should have that it makes the equation true. Let's see if this calculator comes up this time. Nope. Alright, looks like the calculator's not working for us. We'll give it one more try. looks like it's not going to come up. All right. Well, if you put this into your calculator, though, make sure you do put it in parentheses because we are dealing with fractions here. So you put it in your calculator like this. Parentheses 2, instead of x, we would check whichever one we're going to check. So let's say -5 halves. You're checking your solution here. Close your parentheses. -3 parentheses. Raise the second power. Plus 4. When you hit enter, it should give you 68. That would let us know if there is indeed a right answer. So you can check each of these to make sure you did it right. Okay, so let's visit our word problem again. Again, they give us the equation. We have an object dropped. And so let's say, for example, for number 12, let's say that we're on the Eiffel Tower. I don't know what, can't really go the Eiffel Tower or something like this. Okay, here's the Eiffel Tower. We are standing on top, and we drop a watermelon. Right? So this drops a height of 576 feet. And we want to know at what time or how long does it take to hit the ground? Well, the height off of the ground, if it's sitting on the ground, is going to be 0 feet. So we want to know how long does it take to go from 576 feet down to 0 feet. So that's this here. S is my 576 feet. So in my equation, I'm looking for the time, so I'm solving for t, so that's going to stay my variable. I want to know when it hits the ground. My final height is 0, because it's 0 feet off the ground. So leave my t squared. And then my initial height, which is s, is 576 feet. So I'm going to subtract 576 from both sides. To get -576 equals -16 t squared. Punch that into your calculator. Because we're going to have to divide by -16 on both sides. So negative divided by negative will give me a positive value. And I get 36 equals t squared. Now when I take the square root of both sides, remember, our square root and our square root cancel each other out. Square root of 36 would be plus or minus 6. But again, we're dealing with time here. We cannot have -6 seconds. So my final answer is going to be time is 6 seconds. So it should take 6 seconds for that watermelon to fall 576 feet down to the ground. Again, your homework is worksheet 5. Make sure you come see us if you're still struggling with this information. We will have a mini quiz next class. And a reminder, your JLab was due today. So if you forgot, make sure you get it done today. Your next 10-question quiz for JLab is due the following Monday on May 2nd.